This video is meant to explain why certain elements have certain charges when they become ions. Okay? So here we have our central question, why do certain elements create certain charges? And that deals with the amount of electrons they have. Okay? So there's a certain amount of electrons each atom wants so that it can feel complete, I guess is a good way to say it. And that's what's called having a full shell. Okay? When they have a full shell, these atoms are stable, they don't react with things, and they feel comfortable, I guess is a good way to describe it. Okay? So there are certain different types of shells when it comes to atoms, okay? But the two ones we'll focus with the most are the first two. Okay? The first shell has only 2 spots for electrons, and then the second shell has only 8. Okay? So the majority of atoms, okay, that we'll deal with in this class want to have 8 electrons in what's called their valence shell, or the last shell they have. Okay? So if they have 8 electrons, or they feel like they have 8 electrons, they are going to be full, they'll feel comfortable, and they'll be willing to, they won't be so reactive. Okay? Noble gases, okay, which are in the last row of the periodic table, okay, they naturally have a full shell. And this causes them, okay, to be inert, or they do not react. Okay, so noble gases do not react with other elements. That's why they're called the noble gases, right? Because they don't deal with all those other elements that don't have full shells. They are special, they're elite, they're noble gases. Okay, so let's look over here. I've drawn the periodic table for the most part. Okay, and using this information we have, we can determine which elements are going to have which charges for a set number of them, okay, based off of how many electrons they have. Okay, so if they want to have that full amount, okay, elements are going to either give up or gain electrons so that they can feel like they have the full amount. Right? They want to have 8, and so let's say they have too many. So if they have too many electrons, okay, they're going to give up some electrons to become positive ions. Alright, because they're not going to have as many electrons, they're not going to be able to offset that positive charge in the nucleus, so they'll become a positive ion. The same is true if they have too few. So if they're missing, they're a couple short, so they have too few electrons, they will gain electrons from a source. Okay, so they'll become negative ions. Okay, and so there's a certain set of elements that do this in a very specific way, and they'll have the same charge no matter what because of how many electrons they have. So, if you look here at our periodic table, okay, let's just disregard hydrogen and helium. We'll leave them alone for right now. Okay, but as you can see, as I said, the last column here, this last column is the noble gases. So they have the perfect amount of electrons. Okay? So, if we come over here, number 3 is lithium. Okay, lithium has 3 electrons. And as you can see, helium over here is a noble gas. It only has 2. Right? That first shell can only hold 2, so it has a full shell. Right? And so lithium wants to feel like it has a full shell. It has too many electrons, so it will give up an electron and become lithium plus, right? It'll have lost an electron, it'll have one more positive charge than negative charge. Okay? The next element on the list is beryllium. It has 2 more. Okay? So beryllium, okay, if they want to sound like they have a full shell, if they want to feel that way, they're going to give up 2 electrons and become beryllium 2 plus. Okay? The same can be said for the other side. So over here, this is number 10, neon. We've got fluorine is number 9, oxygen is number 8, and nitrogen is number 7. Okay? All of these ones, nitrogen, oxygen, and fluorine, short of the perfect full shell, okay? So what they're going to do is they're going to gain electrons and become negative ions. So for instance, nitrogen is 3 short. So they're going to gain 3 electrons, and they'll become nitrogen 3 minus. Oxygen is 2 short, it'll become oxygen 2 minus. And then fluorine is 1 short. So it'll gain 1 electron and become a negative ion, okay? The cool thing about this then is no matter where they are, as long as they're in these specific columns, okay, those elements are going to become that charged ion. Okay, so for instance, if you're in the first column, you're going to be a +1 ion. If you're in the second column, you'll be a +2. If you're all the way in nitrogen's column, you'll be a -3. And an oxygen column would be -2. Fluorine column would be -1. Okay? So there's a pattern. All of those elements are going to become ions in a specific way. And you can use the periodic table to figure that out if you remember that everybody just wants to be like the noble gases. Okay? Just like you want to be like, movie stars or whatever, or baseball players or whatever, right? Elements want to become noble gases. They're like the celebrities of the chemistry world. Okay? So let's just remember, if you are dealing with ion charges for some specific elements, okay, you can use this pattern based on how many electrons they have to determine their charge. Okay? It makes things a lot easier.